Hello and a warm welcome everyone to our fourth online lecture. Today it is my pleasure to introduce you to my colleague, Mrs. Anastasia Kucheryavaya, who is our scientific coordinator and who will be your moderator for today's session. Enjoy and see you.
Many thanks, Anna, for your nice introduction. Good morning, everyone, from my side too. As Russian myself, I'm very pleased and honored to moderate today's fourth lecture with Professor Oleg Ivanovich Kazanin from St. Petersburg Mining University. This lecture will finalize the thematic area of sustainable mining aspects. Professor, Doctor of Technical Science, Oleg Ivanovich Kazanin is Dean of Mining Faculty at St. Petersburg Mining University. He is head of the university's Methodical Commission of the Mining Engineering and the author of the programs of continuous professional development for managers and engineers of mining companies. Today's presentation will be devoted to the strategies on how to meet the demand for mineral resources, and in particular in the context of the depletion of the reserves of easily accessible deposits and the complexity of the conditions. Also, main trends in the development of mining technologies will be discussed. Please join me by welcoming Professor Kazanin.
Thank you, Anastasia. Can I start?
Please.
Okay, good morning, everybody, dear students, dear colleagues, dear friends. I'm glad to participate in this project online lecture series, Sustainable Development Approaches in Engineering, Research and Education. So it's a very important topic which are discussed now at all levels among people at the schools, in universities, in government, in mining companies. So as for me, the topic of my lecture is sustainable development, modern challenges and prospects. First of all, a few words about content of our lectures. We are going to start our lecture from some facts and figures about mining industry and mining technologies, modern challenges for developing this kind of activity. General technology performance targets for 2030, requirements for high efficiency and safety. And after that, we discuss some trends which we can see now for mining technology development and in which our university participate for development. It's a concentration of mining operations. It's intelligent mine and invisible mine. What does it mean, intelligent mine or invisible mine? What is the features of this statement? We will going to discuss during our lecture. So as for facts and figures, now more than 100 types of minerals are mined. I don't know exactly who calculate this, but at some sources we can see the figures 200. I don't know, but there is a huge number. And the mining industry now, it's a large part of world economy. And every year produced the minerals with a total value of $100 billion. And in the industry engaged the tens of millions of people. So as for volume of production, it's differ for different types of minerals. It can be a few tons, for example, rhenium, 49 tons per year in 2019, up to billion tons, for example, coal industry, the world production more than 8 billion tons. Or sand and gravel, about 50 billion tons annually. Mining production is a necessary part of sustainable development and is a base for almost every business value chain. Without minerals, we don't have iPhone, computers, cars, and many other things which are part of our usual life. With an annual increase in the world's population by 1 to 1.3%, the mineral production increases by 1.6 up to 1.5%. And it's a normal and obvious trend. The life standards are growing, and to support this growth, we have to increase the mineral production because it's a necessary part of development. Reserves to production ratio for minerals also differ in the world for different kind of minerals, differ for different countries. For example, bauxite, chromium. As for coal, if we take the figures for the world, this ratio will be about 130. And as for Russia, for example, for coal, these figures can exceed 600. And now we can see at this slide the challenges for mining technologies, volatility of prices for minerals. And at the plot, you can see the plot from BP annual review for world energy. This is the prices for coal, how they differ from 2004 up to 2019. And as you can see here, in some periods, the prices drops not for the percent, just in times. And for some periods, approximately 30% of coal mining companies operating at the edge of profitability, and sometime under this edge, under this line. And when we going to develop some mining projects, these features as a volatility we have keep in mind. So difficult geological conditions. It is also obvious trends because depths of mining continuously increasing. And for some mines, underground mines for metal ore, I have some figures. 5 of these mines, the depth of mining exceeds 3 kilometers. With increasing on depths, the stress and state conditions, mechanical conditions complicating, getting more complicated. And the hazards of rock burst or sudden gas outbursts, the thermal factors, they became important and start to affect efficiency and safety of mining operations. And we have to choose and to develop our technologies to meet these challenges. Lower ore grade or quality. So it's also obvious trends because deposits with favorable geological conditions is usually already extracted. And we are going deeper. We taking into operations the ore with a lower quality, with a lower grade of metals into the ore. Geotechnical challenges. It's a topic for the separate lectures. So, as I've already told, when we go in deeper, it gets our conditions more complicated. And we have to keep it in mind and to get some measures to overcome these challenges. isolated mine science and infrastructure challenges, social and environmental challenges, adverse community reaction to mining projects. Unfortunately, mining industry has a not so good image, not positive image for many people. And some of them think that who is a miner? They destroyed the planet and this situation we have to understand and try to change. Here you can see some strategies for ensuring future demand for mineral resources. First is a reduced consumption of mineral raw materials, minimization of metal content and final products, how it can be achieved. Use of alternative materials, design of materials, now it is possible and sometimes it takes place. Recycling, so we all heard about circular economy, recycling, and requirements for recycling already include in some rules which mining companies have to follow to operate in different countries. Increase in resource recovery rate from deposits. It's also important thing because in many cases, recovery rate not exceed 50%. So, for example, for some potash deposits, for example. Why we leave underground so much minerals? It can be caused by reason of safety, maybe some efficiency, or maybe we can leave some pillars in the complex geological conditions, but here is one of the way which we can follow. Increase the resource recovery rate from deposits. Exploration of new fields and modern technologies, including already mentioned above, for the development of new fields. So at this slide, you can see the general technology performance targets for 2030. They were formulated in the report of the United Nations on a global sustainable development of 2016. Improve progressively global resource efficiency in consumption and production, and endeavor to decouple economic growth from environmental degradation. So it's a general purpose, and all producers have to follow this requirement. Achieve higher level of economic productivity through diversification, technological upgrading, and innovation. Upgrade infrastructure and retrofit industries to make them sustainable with increased resource use efficiency and greater adoption of clean and environmentally sound technologies and industrial processes. So it's very clear requirements which, as I already told, mining companies have to follow to provide sustainable development. So how these requirements can be transformed for mining technology. So on this slide, we'll try to show some perspective mining technology development trends. Concentration of mining operations. In the next slides, I try to explain what does it mean. Intelligent mine, the wide using of IT technologies at all stages of mine life. Invisible mine, so it's the final points of development of mining technology development. So I think that the mine of the future, it's just a drill hole, all processes underground without people, and from another drill hole, we will get the products which are ready for direct use. So maybe sometimes we construct such kind of mine. And no footprints on the surface, no danger or hazards. So I think it will be really good. But what we have now, concentration of mining operations. What does it mean? Increase of equipment power and reliability. Equipment manufacturers offer a wide range of mining equipment, which can provide a high rate of productivity and reliability. So a little bit, in the next slide, we'll talk about it in more detail. And appearance of reliable and productive equipment give us the opportunity to change of mine plans and technological schemes. It also gives us the opportunity to decrease the number of productivity and the number of extracting units and simultaneously increase the productivity. Risk assessment and control, personnel training and continuous professional development. So it's also a separate topic on which we have discussed separately, separate lecture or maybe a course. Intelligent mine. Also at my next slides, I will clarify what does it mean, how we understand this statement, and what we are doing to support these trends. And invisible mines. Concentration of mining operations, increase of equipment power and reliability. If we can see the history of equipment production, we can see that installed power on the mining machines continuously increase, and now sometimes it achieved big figures. And as for some machines which we can see at this slide, for example, buckled excavator, it can produce more than 10,000 cubic meters per hour. It's a great productivity. And here is a longwall shearer. So now some manufacturers offer the shearers which have installed power of engines more than 2,000 kilowatts. They can produce more than 20 million tons of coal without any repair. It gives us the opportunity to change mine layouts. And the question is how far we can increase the power of our machines and reliable. And from some points of view, the figures and level which we are reached now, maybe it's enough. And maybe we have to learn how to unlock potential of these machines. And in the next slides, I will show you what I mean when I told it. Mine tracks, the load capacity, it can be more than 400 tons. So it's a huge machines. But manufacturers make them reliable. They can work for years and provide a great productivity. Concentration of mining operations. Here is an example of underground coal mining. As you can see here, best longwall's performance, annual production from one longwall, more than 10 million tons. I've saw some figures, such figures as 12 million tons per year. Per month, the record is 1.6 million tons. Per day, 62,000 tons. Per shift, 3,500 tons. In Russia, 2 years ago, 1.6 million tons per month at Yelevskovo mine. Is it a full potential of this equipment? Of course not. At World Mining Congress in 2011, the specialist for Germany, Martens, published some article where he assessed longwall equipment potential. So some statements you can see here, what we await for longwall equipment. Full automation of longwall operations. So at some longwall phases, we already can see full automation. Theoretical productivity of longwall mining of seam with a thickness 4 meters, a density of 1.4 ton per cubic meters by the shearer with a cutting depth of 1 meter and the shearer speed of 25 meters per minute will 8,400 tons per hour. Given 20 hours per day of production and 300 days annually, the early production of single longwall would be about 50 million tons. This would result in a phase advance of 75 meters per day, or 22 kilometers per year. What I have to say, the article was published in 2011. These figures concerning productivity of longwall equipment, it's a real figure. So we have longwall shearers which can provide such parameters. So, and as we see at annual production achieved level is far from theoretically possible. Why we face this situation? Because to provide the full potential using of this equipment, we have to design mining subsystem, transport, ventilation. We have to solve some geotechnical issues and many other things. What I mean when I told that improving of equipment lead to changing of mine layouts and technological scheme. We can see this example of Yelevskovo coal mine. It's located in Kuzbas, Suek Kuzbas, our industrial partner. So here is a part of a mine map. And as you can see here, in 2005, longwall phase, width 140 meters, or 200 meters. It's a longwall panel length is 2,400 meters. Reserves inside the longwall panels about 2 million tons. And what we have now, when we used state-of-the-art equipment, reliable and productive. In 2019, longwall phase 400 meters. Reserves inside longwall panels 11 million tons. The length of the longwall 4,700 meters. So this equipment gives us the opportunity to work to make the longwall panels from one board to another board of mine field. So we don't need divide this mine field on the separate parts, smaller parts to drive the mine workings there, to equip these workings with maybe conveyors or some, or create them in them some other infrastructure. So it gives us the opportunity to make mine layouts more simple and more reliable. So it's much better for companies to have one longwall which produced 20,000 tons per day than to have 10 longwalls. Each of them will produced 2,000 tons per day. Why this? The less people simultaneously underground works underground. It's more simple and more reliable. Some such scheme as ventilation, transport, and many other things. So nowadays we think that the concentration of mining work is good for company, for economical effectiveness, and good for safety. Another part of mining technology is so-called large-scale mining. So in many cases, we meet a situation where the whole company is quite big and have to operate with a big mine, large-scale mining. It creates a special conditions for mining. So when I was a student, open pit with a depth more than 100 meters, our teachers told us that this is a deep open pit, and we have to keep in mind how to provide stability of the slopes, how we provide mine atmosphere. We have to think how to provide ventilation of mined area and many other things. So here you can see the Kimberley pipe Udachная. Open pit operated up to 2016, and now in 2014, underground mine start operation. It's create a lot of difficulties. How can we transit from open pit to underground? What kind of pillars should be lifted to provide safety, to exclude water in floor, and from the other part in this rock pillow we have high-grade ore, and it creates special requirements for technologies. And our university also engaged in some researches concerning this situation. Large-scale mining, open pit coal mine Bogatyr. It was included in Guinness Record Book. Annual coal production in 1985 achieved 56.8 million tons. Nowadays, annual capacity is 32 million tons. Deposit Olympiada, open pit operations planning up to 2030. The depth is 700 meters. Annual production were 14 million tons. And after finished the open pit operation, it also planning to go in underground, and underground mine will put into operation in 2030. And it's also such depths of mining and the huge production rate create some difficulties. The difficulty is how to provide stability of the slopes. So it's a special requirements to the blasting work, to the planning, to the seismicity caused by blasting, and many other things. And how to keep such level of productivity when we going from open pit to underground mining. Another important part of mining technology, its approaches to ensuring safety of mining enterprises. So the safety is a priority number one for all companies, and what we have now. So the first of all, it's a risk assessment at all stages of mine life cycle. There are a lot of methods for risk assessment. Some of them already accepted and implemented into mining practice. Some of them we continue to upgrading. So the question is how to provide the risk assessment in online mode simultaneously. At the stage of designing, so yes, it's quite clear we can assess the geological conditions, our techniques and the mine layouts, and to estimate some hazards and its impact on the future mining. But after we put it into operation, we have to understand how we'll change the risk during the development of our mining operations. So our university also engaged in this activity. Multifunctional safety systems. The safety is also the multidisciplinary topics. And there are different kinds of hazards. For example, rock bursts, the danger, hazard of methane explosion, of water inflow, of roof caving, and other things. And each type of hazards can be assessed separately. And when we made the total assessment, we have to keep in mind all kinds of hazards. And multifunctional systems give us such an opportunity. And that Russian coal mines since 2013, it is a necessary requirement for operating coal mines. R&D support for the development of mining operations. So it's also a necessary part of safety system. All mineral deposits is a unique object, and these objects were created by nature. They are not absolutely the same deposits, mineral deposits. So, and some decisions which that shows good results for one deposits can be absolutely unacceptable for another. And in this connection, I think that R&D support is a necessary part. And also our university and our faculty has experience in this field, and we keep in close touch with our industrial partners, coal companies, ore companies, and many others. Training and continuous professional development of personnel. Also, it's my topic, and I can talk about it for many minutes and not one lecture, but at this lecture we will not discuss such things. This just at this slide you can see just a few examples of risk assessment and control. A well-known system is a risk gate. It was developed by our Australian colleagues for coal mines. It was a good work which supported by many companies and universities, and our colleagues provide such systems, well-based. You can see it at the site. You can enter at the site and can assess some the risk of hazards for your mine field. Different kind of hazards, explosion, fires, and falling, and many others. So, and these systems give the opportunity to assess the risk, to choose the measures for capturing this risk, and it can be useful if we investigated some accidents and enterprises. In Russia, our university will engage in researches, and we developed a method of risk of accident assessment for coal mines in Russia. Here is just a part of these methods, and this methods was approved by our Mine Safety and Health Administration. Now it's a necessary element for designing of mining operations for coal mine. And work in this direction now we continue. The second trend, which I mentioned above, it's intelligent mine. What does it mean? What we think when we talk intelligent mine or smart mine, digital mine? First of all, it's use of 3D models of deposits and technological processes. The use of this allows to optimize processes, use equipment, and maximize profits. The model is transmitted to the operator before the start of mining operations. IT technology is used at all stages of development of deposits, from the exploration and 3D modeling till designing and control of technological processes, logistics, and haulage systems. In combination with GPS, the operator has a complete digital representation of the real production facility, or digital twin, which allows to manage production and risk and generate various reports. A laser scanning system, positional system, sensor of various systems forms a whole big data, a large stream of data that after processing allows you to visualize the actual production. So how look intelligent mine is the source of mine lens, is a part of McKinsey Global Institute. According to them, their assessment, the potential of increasing of mining companies' value till up to 2025, they assessed the 380 billion, 70 billion dollars. So what is the sources of these effects? First of all, operational management, increase in mechanization through automation, monitoring of real-time performance versus plan, equipment maintenance, reduced and scheduled breakdowns, longer equipment life. So all modern equipment also already has the check system, as you can see in your car. So if something wrong with the engine, at first you see the check signal. So mining equipment, modern equipment also has such system. Long haul equipment life, health and safety, minimize exposure to dangerous conditions. And as I've already told, real-time risk assessment. It's also important things to provide efficiency and safety of mining operations. Equipment supply, improved purchasing analytics, Internet of Things, and many others. Improved purchasing analytics, we don't need to have the large store for some parts. So if our equipment inform us about some unprojected things, we can buy some parts exactly at the time when we are needed, not earlier and not after breakdowns. Augmented reality, built on better human-machine interaction, task-based activity monitoring. So how it works? Integrated data platform. We already talked about 3D model of deposits. So also the modern software system will give us the opportunity to assess some mining scenario, different scenarios, and choose the better one, the scenario which provides the better performance indicators. So we have the model of deposits, we have the scenario, and we have, in real life, we have the equipment which equipped with positional systems, with many sensors, and the data from these sensors can be translated to this integrated platform and compare with the ideal variant which already loaded into into our project. After that, real-time mine modeling, predictive optimizations, and command control to our automated equipment. So, and all this just cycle and continuous learning. Experience will accumulate it, and it can make our model more correct and providing better KPI. So we already mentioned such things as equipment effectiveness. And here is the data from MineLens, McKinsey analysis. Overall equipment effectiveness for underground mining not exceed 27%, open pit 39%, crushing and grinding 69%. What does it mean? Here is a huge potential for increasing indicator as a productivity. If we unlock the potential for equipment, we can get good results. And now we work with some of our industrial partners to check it and to develop some measures. How can we increase overall equipment efficiency? How we can increase by changing maybe mine layout, by changing in mode of equipment exploitation or something like that. And to illustrate this moment, you can see long-haul productivity dynamics for the Yelevskaya coal mines in 52. The blue bar, it's a productivity level per month, which is a fact. The red one, it's a level of productivity which can be reached. As you can see, the red one, it just shows the potential of how we can increase the potential, how we can increase indicators of our productivity and indicators of effectiveness of our operations. And to check, to accumulate the data about downtimes, about breaks and many other things, multifunctional safety system, and just a part of intelligent mine concept. As an example, I can present so-called United Dispatching and Analytical Center SUEC company. The main function is automatic control over parameters, indicators, and characteristics of operational objects. Collective display allowing to all participants of the project obtain a simple and full volume of information, which is available in the dispatching and analytical system. Automatic formation of the alarm and precautionary system. Automatic report creation, comparative analysis and recommendations, and many other things, and the mailing to the responsible persons the information within their competence. And here you can see just a video panel. It's this SUEC center. What you can see here, it's a video information, it's a translation in real-time mode from all long walls and from OpenPeak. The information, schematic information about equipment performance indicators. Where is the sharer? What is the floor of a call? And here is information of a multifunctional safety system and information about production process, operational processes. As you can see, 500 windows of current status and 500 reports. It's hard to get some information to analyze it. That's why the so-called the color indications. The green color, all is okay, and all systems work in the mode. All systems work correctly. The blue one, you have to pay attention on these systems. And the red one, this system requires immediate reaction. It gives the opportunity for SUEC to increase the productivity up to 40% since 2010 and decrease the number of incidents. And now this center, this system continue to develop. Another part of intelligent mine, it's autonomous mining equipment. So autonomous mining equipment is not need to rest to make tea breaks or something like that. So it can work simultaneously, and that gives additional opportunities for mining operators, for mining companies. Now we can already see such decisions as autonomous fleets of Komatsu, Caterpillar, Hitachi, and Belas. Now one of the partners of our university is company Cifra, which is specialized on automation of mining operations. And we keep in touch for some joint projects for some companies. Autonomous blast hole drilling operations and equipment manufacturers offer decisions when the drilling equipment can positioning and can drill autonomous according to coordinates and parameters which will be loaded into the computer. Automated long-wall sharer systems. So already we have some examples how it operates at the real coal mines. And Avatel, first mechanized development charging systems. Orica CIS is one of the partners of our university, and every year we have the seminar where our colleagues from Orica present the new achievements in equipment, in blasting, designing, and many other things. And, the last one was this Avatel machine. They developed it together with Epiroc, and some elements such as explosives and detonators, Orica, some elements Epiroc, but it's the first mechanized development changing system. And it gives additional opportunities for safety, for increasing productivity of development operations. Also, Orica developed and support BlastIQ system. Every day they produced more than 1,500 blasting all around the world, and the information about each blasting just collected, processing, and accumulated in BlastIQ. That gives opportunity to increase the quality of this project and to solve any task connected with blasting. Intelligent mine, some features for this mine: autonomous mining equipment, and part of this equipment will be extended. It can be remote operating center located in urban centers. We also have some examples of such situation. The operating center located far from the mine site. Off-site services for specialized machine health diagnostics. Fewer operators, but more highly skilled personnel you are required to support, to develop this concept. And I have to mention a report, Mines of the Future, version 1, which was presented Society of Mining Professors in 2019. So it's very useful documents, major findings about autonomous mining, intelligent mining, and some parts devoted to off-earth mining or mining and sea mining. And the next step, invisible mine. As you can see here, what does it mean, invisible mine? First of all, it's a planning of mining work from trees to trees. It's not only planning. We can design, we can plan such way of operation, but as we can see, the prices can drop significantly, and it can lead to the bankruptcy of the company. But this situation will not will have not to influence on situation with the environment. So the work from rehabilitation have to be done in any way. Integrated use of minefield resources. It's also the separate topic, very interesting topic. When we come to the minefield, when we start mining operations, so resource, it's not only mineral resource. The space which we create underground, it's also one of the resource. Mine water, it's a resource. The rock mass which we don't use, we can see on it like a material which we just don't know how it used now, but it can be used in the future. So we can use underground space for disposal of solid waste for mining and processing of minerals. When we deal with ore, with a low grade of metals, it's very important to organize underground near-face processing, to not transport and lift on the surface a huge amount of the rocks. Transport, process, transport, and organize the storage of it. A mine-to-mill concept. It's also interesting concept, and also it can be a separate lecture. And the best available technologies. In many countries now we have the reference book which collected the best available technology for mining minerals, for processing, and for many other things. So in Russia, we have more than 50 reference books with the best available technologies. And 5 of them directly connected to the mining industry. So here is just some criteria. Minimization of mineral losses in the mine field, availability of modern high-efficiency equipment and technologies for the treatment of wastewater and emission pollutants, application of measures to reduce the release of pollution to the atmosphere, availability of recycled water supply system, drainless systems. Application of drilling and blasting technologies aimed at minimizing and negative impact on environment, use of technological waste, arrangement of waste disposal facilities that minimize the impact on the environment, and many other things. And at the end of my lecture, the role of university in supporting and in development of this activity. First of all, it's a training and graduation, the world competitive specialist on the basis of integration of the research and education. Our economy are global and the mining industry are global. Requirements for the mining engineers, for the mining technologies, getting the same all over the world, and the task of the universities to provide training and graduation. Researchers, promotion of the mineral sector technological development, development of international cooperation, and popularizations of mining and the miners' professions. So it's a very important thing. And if we together will develop our mining technologies, it will change the image of the industry, and our task, our and your as students and future mining engineers to develop mining industry, to make it more environmentally friendly, to more attractive for young people. So I wish all of you success in your professional development and your personal development. Thank you for your attention.